Well, this is Old Electronics Fan, and I have a bunch of stuff I want to talk about in part 3. This is the Hallicrafters S-38B. My memory's so bad. Yes, S-38B. It's a good thing I had some of that model number left on there because I would have been totally lost. As most of you have figured out by now, I had no idea what I was buying when I bought this. Hallicrafters is a name I've heard, fairly often, but I didn't know much about it. Number one, I have not done anything whatsoever with ham stuff other than back in high school when I started learning code, Morse code. So when I got this, I didn't quite know what I got. Like I said, it was an impulse buy. I recognized the name, thought it might be fun to have. It's multiple shortwave bands. So I thought, okay. But on the switches, there was a label here that said CW. I thought, that's interesting. Makes me think of code, Morse code. Well, it turns out that was correct. But I didn't know that CW also meant a continuous wave. That is what that means, by the way. So, like I said, I didn't know much about this radio. When I got into it, I realized that it could receive Morse code, but it couldn't send it. And that's kind of questionable as it stands. BFO, beat frequency oscillator, I recognized the term, but I didn't know what it was exactly. I'd never dealt with it. I didn't know what it was for. Now I know that with a decent beat, BFO, it would allow you to hear the tones that are being produced by people doing Morse code, and also it would allow you to listen to single sidebands, because the beat frequency oscillator could clear up and make audible the audio that's on the single sidebands. Unfortunately, this version of the Hallicrafters has, well, to put it mildly, the BFO in it is a joke, and I want to go over that shortly. But as you can see,
All the good love.
it's playing really well. I can't play that without getting clobbered. I played around with the shortwave part, and I played with this, and on one of later in the day, this is earlier, this is before noon, I was able to put my needle right here, and I was able to use this to find multiple channels. Right now, even though I've changed my antenna and I've run it up higher and longer, so it's at least 12 feet higher than it was at the very end, it's still not, it certainly isn't helping the AM, unfortunately. So anyhow, so there's that. Okay. There are a bunch of things I want to go over with regard to things that I learned along the way, and things that I want to share with you, because if you're working on one of these, there's a few little things that could be confusing or could cause you to maybe have trouble finding what you need to find. So let me think here. Oh, alright, let me turn this off. And like that. There goes my antenna. Alright. This. Back, maybe video 1, I was questioning why this piece of paper was on here. Well, I know why it's on here now, and that will get into the safety of this radio and what I want to do to change it so that it really will be safe. This case, if the plug is plugged in, go either this way or that way. Well, if it's plugged in one way, this case is a full 120 volts. So without this on here, people could touch this and let's see if, well, that's interesting. Well, you got 3 rivets that actually go to the chassis. So if you were to touch those, you'd be touching the chassis. I guess the idea of this being on here is when you have the back cover on, it protects you from anything surrounding these. So there's that. Okay. Then, and I am going to get into the safety wiring, so you'll see exactly why. Well, actually, I just explained why. Never mind. All right. This is one that also bothered me. And what did I do with that? I'm determined to use... Oh, there it is. Okay. Let's bring you in a little bit here. See this? Well, at the time I was questioning this. Why on earth did they have this? Because if you look on here, in fact, let's see, that would be well, that's the other thing, and I don't know what they were doing. Yeah, these, that says C5, C5, C5. Oops, so you can't see that. C5, C5, C5. Well, these are actually those, and now maybe this one was referencing a note. Actually, I don't know if there's one for that. But it would have been nice if they had said, you know, R7, R11, yeah, R7, R6. Let me just see here, R5, R6, and R7. Yeah, no. So R7, there's no note associated with this. There are notes, for instance, this one right here. This is, in this radius, a 2.2 meg, and the note tells you that some sets did have that size resistor. Why they did that, I don't know. The other thing is, this actually should be a C16, which I've noted here, because this is actually C17. If you look at the picture and the arrows, that is indeed C14. This one is indeed C16. So that was just a mistake on there. This is PhotoFax Sam's, so I guess that's not entirely surprising because that happens. Now C17 is called a line isolation capacitor, and if you look at this, this is the only way I knew where it was. C17 goes to this, and I'll show you underneath in a minute. So, yeah, I'll show you that in a minute. But C17 is here. The chassis is this little piece right here where the switch is. There's an insulator here, and I'll show you, like I said, in a minute. This is confusing because I thought that the chassis would be the symbol. Let's show you what it is on this. Get this unplugged so I don't yank stuff I don't want to yank. Alright, let's back off a little bit. Alright. And flip the upside this way around. This is the chassis they were talking about. That chassis symbol. That's it. That's the chassis. This is the capacitor. Now, you want to do that. Not recommended that you do that. I'm glad it wasn't on. And the tubes are cool. Hopefully I didn't harm them. Trying to be careful not to handle it in certain places and let her drop. That's not good. All right, so let's. All right. Now, I think in the previous video I talked about, well, that's not going to be any good. I talked about not replacing this and not replacing this. Well, I thought about it, and I decided that I really did want to change that. It's just going to go where I want it to. I don't know. All right. My goal is to make the chassis always neutral. But the other job of this is to, well, they call it line isolation, but usually when you have a cap between, say, B minus and the chassis, it's also dealing with RF noise and such. What I remember to be correct is, and they do have one C15 RF bypass. C15, which is, where is C15? Oh, right there. Okay. And that's on the rectifier. And C15 is 470 picofarad. Alright, so they're calling this an RF bypass. Yeah, RF bypass. And that goes from this pin down to ground here. So, RF bypass. That's right on the rectifier. RF bypass. Oh, okay, so that goes from, alright. So, on here, this is, oh, come on. Alright. That's this right here. So I guess they're trying to get rid of RF noise here. It's part of the filtering system. You've got the pi circuit, filtering circuit here with the two capacitors, actually three. They've got one more here that's designed to help, I guess, reduce noise, RF noise. Anyway, but I believe that the, let's see, that one would be, I should have looked at this more closely. Okay, 16. What does 16 call itself? Line filter. Okay, so, oops, let's go back here. Alright, so this is called an RF bypass. And let's see, yes, I showed you that. This one goes from this pin, which is, and it goes to ground. I knew what that was. And you are pin 2. Alright, pin 2 of the rectifier. Okay. Alright. And that is C16, line filter. Alright, so I guess I gotta aim it at the right thing, don't I? Alright, so that's the blue one. This is the XY cap I put in, safety cap. But again, that's designed to filter out noise, line filter. So again, noise reduction, probably trying to deal with RF stuff. But this radio, yeah. I mean, a lot of radios that I've worked on, B plus is raised up so that this is B plus, or B minus rather. And then the actual chassis of the radio, the metal chassis, would be this part. And so you've got a capacitor between your B minus and here. and it's there because on a lot of these radios, again, depending on which way the cord goes in, B minus would either be full 120 volts or it would be neutral. So anyway, there's that. But this is what was confusing me, because I expected the radio chassis to be that, and I couldn't find this until I looked. Thankfully, that number was correct, and I saw the picture. I said, "Oh, well, that kind of makes sense." But anyway, now in my reading, I discovered that the S-38A and S-38 both had an actual BFO. There's a tube for that oscillator, for the BFO, but they eliminated it in the Model B going forward. And so, as I was reading, one of the descriptions of the BFOs was that they were taking the input of this tube and feeding it. They're basically coupling the input and the output, and that's how they're trying to get the oscillation and make. It's a poor man's way of doing a BFO, basically. So, I was looking for these capacitors and I couldn't find them. Well, I found them. I went looking, and starting back here. Whoops. Let's go back here. Let's go. All right. So we've got this big brown wire. This goes down to the AM-CW switch down here. Travels all the way up here and goes into here. And let me zoom in. Oops, up there. Can I? Maybe I can just tweak this a little bit. Yeah, there you go. This is one side of the IF can coming out of here. It's twisted around this wire and going into this tube. And I believe this is pin. Which pin are you? It's like, I had this at one point. That looks like pin 8. Yes. So this is pin 8. And so this is the output. But here's what's really wild. Over here is pin 4, which is the other side of that tube. And it's the 12SK7. What they did was they ran this wire over here and just tucked it around. There's pin 4. And they're calling this close coupling right here, they're calling this a capacitor. So this is a capacitor, that is a capacitor. So when you look at, oh, stop it. So when you look at, whoops, not that. So when you look at this, these are the two capacitors, and this is your BFO circuit, and that's what this AM-CW switch does. And if you have a real BFO, you turn off the ABC, which it looks like, I'm thinking that if the switch is in this position, that's CW, because this is the ABC line, and it would then go to ground through that resistor. And then you flip it this way, that grounds this part of the circuit and turns off the BFO. So that's my conclusion regarding that, but I spent a little bit of time wondering where the BFO circuit was, and the description of it is what enabled me to find it. It said, oh, pin 4 is the input, pin 8 is the, that must be 6? I don't know. The printing in this is actually pretty good for the most part, but there are times, I think that's 8, I think this is 6. But it's hard to tell because it's kind of blurred on that number. I could dig into it, but it doesn't matter because I'm pretty sure yeah, it's the plate. Regardless, it's the plate that it's feeding. So basically, it's doing this, using this loop to mix signal and try to mimic a BFO, which I guess it doesn't do very successfully. So, oh yes, Here's the last thing I wanted to show you, and I am going to do this maybe off camera, I'm not sure. I know you can't see anything. Alright, I think. And the one I'm looking for is down there. Right there. So, let's see if we can get in there. I want to show you something. Because of the way I was working on the radio, I didn't see this at first. Can I get it from this way? Yeah. See that? That's cracked. It's actually broken. It's been this way since the radio was new. Thankfully there was still a good connection there, or well, I've run into those before and they're trouble. I actually caused one when I was working on an FM tuner, and it was really fun trying to find it, especially since it was intermittent, my favorite thing. So there's that. This is the spread band. This is fine tuning for FM. Now I don't know if I did this or if somebody else did, but this wing was bent out so that when I closed it, it was causing static. And if you're taking this tube out, do that, because it's very easy to just have it hit that and bend it. But this is how the spread band works, this fine tuning, whatever you want to call it. It's actually inserting these fins into this other part of the the tuning capacitor and changing the capacitance a little bit. Clever idea, actually. So anyway, I'm going to leave that like this. So if you are trying to tune something in, you want that here, and then when you get it sort of tuned in, then you can adjust it. And if you go slightly above the signal, then you can get more range to either side of that signal. Using this. So anyway, but you want to start off this way. Like I said, I had on one of the bands, maybe the one closest to the AM, like maybe that one. I had this here, and I was using this, and I was actually able to dial in using this, like two or three different channels, or stations, I should say. So, anyway, I'm all over the place. But, do I want to go this way or that way? Maybe I'll go this way, I guess. I'm getting this set up because I want to show you something, and let me back off a little bit here and get that out of the way first. Now, let's go back to the power supply, and actually I want to have both of those. I want to have this in view and this in view. Now, it's not hard to figure out, but the way this is wired up, this ground point and this ground point are tied together right here. This ground point and this ground point are tied together in that tube that I'm going to show you in a minute. I thought, well, it'd be pretty simple. It would be pretty simple if I were to just kill this, which I'm going to, by the way. Kill this ground, and then I'm going to tie together. Yeah, I didn't want to go downhill like that. That's what I get for doing things live. Alright, so we're going to go from here over to here. Anyway, so this is going to go away, this ground, and this ground. So what's going to happen is this side is going to be the hot side, And the reason why you want it to be the hot side, because if you look at this, having a capacitor between here and here will keep you from getting the full AC. But you still have the, you can still get bit by touching the chassis or having it near another grounded surface, because there is some AC, a little bit of AC getting through here, and so yeah, so you can get a little bit of a bite off from it. So you don't want this side to be 120 volts. That's not where you want that. So in order to do this, you have to make this the hot side, make this the neutral side. Now it looks pretty simple, so let's take a look at what we've got to do to get to that. And there we go. And let's see. I think this is the one. I think it is, pretty sure. Well, let's. All right. So if you look at this, this is the 12. This is the 12 SQ7 pin 8, and that's where the filament chain goes to ground. All right. So yes, this is the right tube. This is the 12 SQ7. So this is let's see. Oh, this is also interesting. Something is not adding up here. Well, let's grab a meter and see what that's supposed to be. Something odd there. You think I'd never read a resistor before? Well, let's find out. Let's see. This is supposed to be, we're going to double check this, 13.9. Huh. Okay, that doesn't, okay. This, if I read this right, brown, so 1, 2, and what's that? 7, blue, 6. All right. All right. So this is supposed to be 12 megs, according to this resistor. According to my schematic, it's supposed to be 15 megs, and that is going to pin 2, I believe. Yeah, they do. All right. What they've done here is they've tied these two terminals from the tube here together. That's pin 1, and this is pin 8. And when you have a metal clad tube, pin 1 is the shell, and it is grounded through pin 1. So pin 1. See, there's a wire down here that goes to ground. So pin 1 and pin 8 are both grounded at this point. And then this resistor is grounded also, because that well, whatever that meg is, goes to ground. I've got to unsolder. Now the other thing that makes it fun, and they do this a lot in these old radios, this leg of this resistor goes through these two connection points on the tube, and then goes down to ground. So the ground, so this resistor actually goes to ground here after it goes through these two connections. So I'm going to have to unsolder this wire from the resistor from here, take it out of here, unsolder the, separate these two, because I no longer want this going to ground. And I'm going to have to run a new wire from here, probably down here. Now, there's a couple other things that I want to mention. When I was figuring out how to do this, I came to the conclusion I don't have a lot of choices. I can't use this connector back here because I don't have any way of ensuring that the where is it? Where are you? Where'd you go? Okay, yes. Not you. This one. All right. I don't have any way of ensuring that this gets plugged in the right way every time. There are no ears on this. There are no way to put ears on them. The wire itself is not healthy. It's got a split right here. The wires are going to break fairly soon. It's not healthy. So I pondered this a lot. And so my question was, what do I do? I could kill these rivets, put a metal plate in there, make a hole in it, and then put a grommet in there and feed my AC cord through there. I wasn't entirely sure I wanted to do that. So then I thought, well, what if I, when I was looking at the back of the case, I noticed that this cover, the rear cover, was offset slightly, so I could actually feed a cable alongside it. Well, the problem with that is, don't you dare do that. Stop it. I've already done that once. I don't want you doing it twice. That was enough. I need to get something to help me work on stuff, and I had the design and then I misplaced it. But anyway, that's another thing for another time. All right. So, one of the things that you will always notice is that the rectifier and the audio output tube are all on this end of the radio, away from the front end. And you notice that the wiring coming from the outlet goes up along behind and under things up here to the power switch. So, given what I encountered here, I mean, maybe I could feed it alongside here and secure it and feed it in this way, and it might be okay. But what I've decided to do is I've already added this little tie strip right here. I'm going to cut this ground wire. There's a wire right here that goes over here to this leg of the volume control. So this is going to get cut. This wire is coming out, and then another wire is going to feed down here over to here. And then I'm going to take a wire to run from here and feed it down and over to here also. And that will get me where I want to go. I want to wind up with this side of the circuit not grounded anywhere, and then ultimately I'm going to feed what I'm probably going to wind up having to do, which I don't want to, but if I feed, where's my cord? I saw it. There it is. Ew. If I feed this cord alongside here, there's a very good chance that I'm going to have to notch this cover just because of how tightly it fits here. But the wire isn't that thick, and I think I can just notch it a little bit so I can feed it in and feed it into there. And that way, this polarized cord will then give me what I want. There's no, short of finding a replacement for the one that was stapled to that back cover, which chances of that are like slim and none. It's just not going to happen. So, I'm going to rewire this. And yeah, it's a bit of work, but I really, really, really don't want it. If down the road somebody else winds up with this, I want it to be safe. And this is the best way to do it. Obviously, if somebody has their house wiring wrong, or somebody did their own electrical wiring in a room, this could wind up being hot, which is another reason why I replaced this and I replaced this. I replaced this because it was really leaky, and if this is supposed to be for filtering RF out as well as line isolation, I wasn't sure how well that would work. So I want to make this okay. This goes straight to ground, which means that you could have the same problem of an AC tingle coming from this if you were working with the antenna connections here, and the cord was plugged into an improperly wired outlet. So I wanted to make sure this was healthy. This was pretty leaky also. So that's why I ultimately replaced those. I wasn't going to, but I ultimately decided that I didn't want to leave them the way they were, especially after I tested them and found out, especially this thing. This thing was leaking at 25 volts on my C3 tester, so it was really bad. So it just, to me, that was just no question that had to go. Alright, so I'm going to rewire this all, come back, show you what I did, and maybe by then it'll be later in the day and we can get more out of the shortwave, because I think it was in the afternoon when I was playing with shortwave and I was getting some stations. There's not much on shortwave anymore, unfortunately, but there are a few things, and I might be able to show you how this thing behaves. If you have a couple of stations that are right close to each other, you can actually use this. This adjusts the capacitance enough that you can actually pick up multiple stations just by using the range of that band selector or band spread control. Alright, well, I have finished. I have my new power cord attached. And as always, when I make changes like that to a radio I'm working on, I turn on my light bulbs. So, let's see, that's on. We'll turn this on. I use a different bulb this time, because this one, it's a 75 watt equivalent, but it's actually 43 watts. And so that looks good. So we're going to go there, bypass that, and get my speaker connected. Huh. Well, why? What did I do wrong? Well, I have to explore this. Let me show you what I did, and then I got to figure out what I got wrong. Nothing's looking bad. Tubes all look good. Nothing's smoking. That was happy. Alright, well, I'm not sure what I did. Let's take a closer look, and then I gotta figure out why it's not working like it's supposed to. And maybe the mistake is down here, but we'll find out in a minute. Oh, wait a minute. Is this... Wait a minute. Which way does that button supposed to go? Stand by. It's down. Okay. So that's not in the wrong place. I've gotten bit that way. Alright, so over here. I left this ground wire here, removed it from here. I've added this wire which went down over here and goes over to the filament. And since the filaments are working, that part looks good. Then down here, So down here, the wire that used to go over here to this plug goes here, and then this is the other side of the filament circuit, I believe, and goes here. So this should be the neutral side, this should be the hot side. I guess I'm going to have to play around with this and see if I can figure out what's going on. So right now, this is the hot side. This is the neutral side. So probably what I should do is see what I have for plate voltage here. Like I said, it shouldn't matter because you can plug this plug in either way, and sometimes you get the neutral, sometimes you get the hot here. So let's see. And that's supposed to be on pin 5. So and if that doesn't show me or tell me something, then I'm going to have to look elsewhere. Let's back out. Alright, put you there. Put you there, put that there. And pin 5, which is let's see, 2. It should be that one. Right? No, 1, 2. Yeah. 1, 2, 3, 4, 5. So those two should be tied together. 0 volts. Well, that's not good. Yeah, because what's this? 0 volts. Why? Why? Oh, you know what? Let's try this again. Maybe 37. Pin 5. 1, 2, 3, 4, 5. It says negative 97, or 0.97. Yeah, that's not right. That's why it's not working. Well, surprise. Let's go to, and choose that. So, 124 volts. So theoretically, let's go back to DC actually. That's what we want. Oops, no. Let's go back to DC. And well, the filament bulb is working. Or the pilot light is working. So that part of the circuit is indeed working. Can I'm thinking. Alright, well let me go back to, let's go to the 100 volt one, which is 60. Let's see what voltage we have there. Right there. Minus 1 volts. Yeah, we don't have any B+. Why? Why for no B+? Now I was questioning that, but this is not making any sense to me because, well, I gotta think about that because this doesn't make any, well, it kind of does. I'm feeling a little more than a little bit dense here. Now you would think with the studying I did on power supplies for this type of radio, that I would be more aware of what is necessary to make the power supply work properly. But, well, it's a combination of things. I was reading someone else's ideas on how to make this work, and it wasn't that they got it wrong, it was that they did it differently, a little bit differently than the circuit they were using. The way they wrote it up is a bit different than this here. In fact, I think what they did was they had the ground going here, and then this just went straight over to the beginning of the, or the end, whichever filament chain. But regardless, I didn't pay enough attention to what they were doing, and I wasn't really paying attention to what was happening when I changed this circuit in a way that, well, it was different, and I missed something rather important. So this cannot go away. Without this, notice you've got power coming in here, going here. If without this, all you've got is the filament circuit, which is all I had. This, and this, notice this goes to ground. This should have gone to ground, because in order for the AC coming in, to get to the rectifier and to get V plus voltage here, this has to be connected to this. You take this away, now all you've got is your filament circuit. That's it. So that was my mistake. I didn't pay attention to the fact that by removing this, I was breaking the circuit, basically. So that was, and how I figured that out was, let's see, can I get light there? Well, anyway, I put this clip lead, back out here, I put this clip lead to the chassis, which is ground, and then the other end was connected to here, to pin 8. And lo and behold, it works. So, what do we have to do? In fact, I'm going to, oh, the other thing, since I'm re-recording this section, and I have to mention that because there's the tail end of this involves this. I should have known better. Okay, let me back up. Trying to get my thoughts in order here. Okay, when dealing with radios where they have a floating ground, where they look like this, where you've got your B minus is actually floating, and then you've got a capacitor that goes to the actual chassis, unlike this radio, then you can have a problem, and in this case you wouldn't have this, you would actually have a capacitor going from either here to chassis or here to chassis. Either way, it doesn't matter. And the reason that thought was in my mind is that when you have floating V minus and you have a capacitor going down to chassis like this, when you have your cord connected such that you have hot or 120 volts on this side of the capacitor, some AC will leak through this capacitor to chassis, and it will give you a bite. I had a C3, I think it was my C3. It had the setup where it had the floating B minus, and then it had a capacitor going from B minus to the chassis. Well, I had something sitting next to it that was actually grounded. In fact, I think that had a 3-prong plug. So the chassis of that unit was grounded, and it wasn't floating like this one. So when I touched the C3 and the other item at the same time, I would get bit. There would be there would be voltage there, enough that I would know it. I would notice it. And that's what I was thinking about when I was worrying about this. But the reality is that this and this are tied together. When this is neutral, so is that. There isn't going to be any voltage here. In fact, there's not going to be any voltage on the chassis. And I don't know what I was thinking. You know, because I'm checking to see if there's voltage between chassis and the ground connection. If you have a 3-prong, go to a 3-prong outlet, or in my case, I have my signal generator, which has shielded connections, and the shield on that goes to ground. So if I connect to ground on that and I check it, and I check between it and chassis, if this chassis is hot, or it's plugged in such that this is hot, then I will read the voltage there, pretty much 120 volts, or thereabouts, I think. It's been a long time since I've done that. But in any case, that was what my thought was, that there'd be volts. If this was going to be hot, therefore it'd be 120 volts here, and there'd be some leaking through to here. But number one, the voltage is going to be really low. But number two, this is going to be neutral now when plugged into any normal outlet. So later on in the video, you'll see me testing this and getting voltage readings, because I was still thinking this setup rather than this setup. And I don't understand why I didn't see that initially, why I didn't see that right away. I was actually editing this video when I looked at something in the video, and I looked at that and said, oh no, that's wrong. What I just said is wrong. I need to redo this. So that's what I'm doing. I'm redoing it. And so let's show you my rewritten diagram. So now, neutral side, polarized plug, of course, and you don't need a ground here, you've got one there, and because this is now all one wire between here and here, and because your on-off switch is going up here between this point and this point, you don't need two grounds anymore. So I put a ground there, and now this is always hot, properly wired outlet, of course. It's always neutral. This is always going to be at 0 volts or thereabouts. Yeah, that fixes the problem, and the radio works now, of course. I checked the B plus voltages, they're good. In fact, I think I checked them, and they were, I don't know if I have no idea what's going to be left of this video once I get done chopping. But I did check the B plus voltages, and I believe they're correct. 12SQ7, I think, is where I was testing it. Actually, I was testing here, and this was reading 68 volts at this point. This is supposed to be at 65. You've got a resistor in there. I don't think it's going to be really high current, so you probably probably somewhere around 65 volts there. In any case, I think the voltages are good. The radio's working great. I don't think there's any problem whatsoever. It's got plenty of volume. So is there anything else I need to mention? I don't think so. So yeah, so to properly rewire this and make it safe, this is what you want to do, not what I did initially. I left that part in because I wanted you to see the mistake that I made and show you the solution. Hopefully, I'm pretty sure that there's a lot of sharp people who watch the videos on electronics, and so they're probably yelling at the screen saying, "You turkey, you did it wrong. You turned off you disconnected your circuit. You broke the circuit by leaving that out." And it's exactly what I did. Now, I did an experiment with removing this capacitor and grounding here, and it's not necessary. This works perfectly fine. And this, okay, the purpose of this, let's go back here and let's zoom in a little bit, because I want to, because I think this is called, let's see here. One of the things about this, the information that I found for this, is that this is a C16 line filter. So this capacitor is called a line filter. Now, my original thought was that it was trying to filter out RF noise. Well, I've got this capacitor right here, this 470 picofarad capacitor. This is going to act like basically a short circuit for the higher frequencies like RF, IF. So anything that shows up here is going to go to ground. It's going to be removed. So why do you have this? Well, because this, and you notice that this is a 0.02, not a picofarad capacitor. There's other noise, especially around the 60 cycle range. In the lower frequency ranges, there's noise that could come in through the power. And by having this capacitor here and bringing it to ground, it's helping to filter out the noise. They call it a line filter. That's the purpose of that. So when I was originally thinking that this might be a problem because I hadn't yet made the connection, so to speak, I was still reluctant to remove this because of the function that it has. So thankfully, now that I understand things properly, I realize, number one, I don't have to get rid of this, and I don't want to, because if there is any noise showing up on this will help get rid of it, and then this helps filter out noise as well. And of course you've got all this filtering happening here. So there's a lot going on here to try to make sure that the radio is clean and you don't have some extraneous noise coming in. One of the things that surprised me, and I don't recall mentioning it in the later part of this recording, did I mention? I can't remember where I did what. I probably mentioned this, and I'm going to be duplicating what I did before, but let me show you what they're calling chassis. Now, let's go over here. Alright. This is what I would consider to be the chassis. That's what this says, denotes chassis. Most radios, this is it. This points to this. Not here. It's this. This is nice. There's this little plastic thing here. That isolates this from this. This is not directly connected to this, which is why you have this connected to it. This goes from the chassis to this. I guess you could call this a sub-chassis? Kind of tiny. But anyway, so what I found rather interesting was that when I measured from here to the ground on my signal generator, I had a volt. I was rather surprised at that. And I have a feeling I probably mentioned that. I'm still not entirely sure why that is happening, unless this capacitor is just building up a charge. I don't think I mentioned. I was trying to remember what was in the what is in the section of the recording that will remain when I'm done. I didn't mention why there might be voltage here at all. Well, think about this. This ground, of course, goes to here. Two-pronged cord. You've got, if you look in your outlet, you have the black hot wire connected to this. You have the white neutral wire connected to this side. But you also have, because we now have three-pronged outlets, you also have a ground wire. So you've got hot, neutral, and ground. What's going to happen is when I connect to my frequency signal generator, I'm actually connecting to the ground wire. The meter is measuring through the ground wire, and since the neutral wire is connected to the same spot in the box as the ground wire, the signal path for the voltage is going from my meter through the ground wire back through the white wire to here, or actually to here. Oh no, that's right, because this is the ground, that's the ground, okay. So what's happening is it's traveling through the ground wire, back through the white wire, and into here. That's enough wire. Even I'm in the basement, so the distance between here and the breaker box isn't all that great, but it's enough. So having my meter connected to the ground wire and having it go through the ground wire and the white wire to here, there is enough resistance in that wire for there to be a voltage drop. And I believe that's what I'm measuring at this point. Between here and the ground on my signal generator, there is a tiny millivolt voltage drop across the wire because there's some resistance there. It's still kind of puzzling as to why I get like 200 millivolts here, but I get a volt here. It's strange. But anyway, so I'm trying to remember what else I need to put in here. So I think the next thing you're going to see is me measuring the voltages here and here. And just bear in mind that this was recorded after I got a proper understanding of what was going on here. So, yeah, I'm going to leave it in there just because I make mistakes. I don't see things clearly. I could hide that, I suppose. But, so what I learned from this, and what I hope I learned from this going forward, number one is it's all well and good to get information from other people. Just pay attention and make sure that what they're talking about and what you're looking at are the same. In my case, this circuit diagram is slightly different, and in their circuit diagram, or in their instructions, they said remove the ground here, which is what I did. I didn't think about what that would do to the performance of the circuit. So when you're getting information from other people, number one, people are like me, they can make mistakes, they can misunderstand things, so be careful. And the other thing is, this I just flat out missed, and I just did not think through the fact that this and this are tied together. That's maybe, is that a downside? I don't know. I guess it's just me not paying attention to the fact that this and this were tied together, and there shouldn't be any voltage on here because it's on the neutral side, and it's always supposed to be if things are right. So, had me running around in circles a little bit, had me wondering what I had done wrong. Thankfully I figured it out. Thankfully, when I looked at this circuit diagram and I spotted, I said, oh, uh-oh. And yes, yeah, it was uh-oh, all right. Okay, on with the rest of the video. Well, it's working. I got it fixed. Back on that tube. When I put this back together, I put a jumper between here and here, so if I have to replace this, which I didn't replace, by the way, I could just unsolder the resistor and I wouldn't have to worry about chasing it through there. So, in order to get this to work, I put another jumper from here to here. This is the pin 8, which is the last connection in the chain for the filaments. So the other thing I had to do is I put this wire in and I ran it down to here. So this is the neutral side of the wire. So that runs to ground, which it has to. Now, and then down here on the bottom, this is the wire that goes to the on-off switch, and then this wire comes back down to from the on-off switch back here. Originally there was a wire that jumped from here over to this to the plug. So let me show you my wiring diagram. Let's see. Now, all right. So I didn't pay attention to what he had drawn out. What he did was he actually had a ground where this is. He grounded this, and then this part was ungrounded. But like I said, I'm going to plug this into a regular outlet in a moment, and we're going to check the voltage between the chassis and the ground. When I have a ground on my frequency generator, signal generator, and I use that if I want a quick ground for something. And so that will tell me whether this capacitor should stay. So I'm going to hook this up down here, and I guess we'll get that out of there. And I have
had one of those engines fail for anything other than timing components.
Alright, so
They just last. They're very strong. The part is the weak part, but again, it's the lubrication that keeps.
okay, seems like it was drifting. So I'm going to ground this, and then I'm going to take my meter and we'll get one side to this and go to our AC settings, millivolts. well, that's all it's saying. Oh, you know why that's doing that? Okay.
Budgeting for, or
Well, there's tests that get done. I just want to make sure they do.
Once again, my CW switch was down instead of up to AM. Alright, so, yeah, I've got 265 millivolts. I don't think you can see that in the camera, but it does say 260 thereabouts. So, I'm going to be brave. I'm going to touch this. Okay, well, nothing. I'm not getting bit. Kind of surprised, but yeah. Well, that was fun. Now, yeah, I guess when you are following someone else's instructions, but you aren't paying full attention to what they did, and you think you know what they were doing, and then you find out, oh yeah, I'm doing it differently. So I'm kind of surprised. Oh, let's see. What did I just do? All right. Oh, there it is. I don't believe this is going to make any difference whatsoever. AC. All right. So this is the chassis. That's 256. Oh, that says 1 volt. Really? Well, that's interesting. Huh. Why? That's a volt. Why? That's interesting. It still doesn't bite me. I mean, 1 volt is nothing. But so, wiring it up the way I did will work to make this thing much nicer to work with. Yeah, I did quickly check the B plus voltage on this, and when I was trying to figure out my problems with why this thing wasn't working, and I think 65 volts. Yeah. Well, anyway, I was looking at the voltage right here, the last thing in the chain. I was getting 68 volts there, and I think that lines up pretty well. 12SQ7, pin 6, yeah, 65, I think I had 68 volts. So the voltages are good. I think this is working as well as it's going to. So at this point, I'm going to call the electronics part of this thing done, because I think I've done what I need to do. I certainly learned a lot, and that always makes me happy. But here, this is a problem. And yeah, I noticed that it was not in great shape when I bought it. You know, I'd like to get, it looks like they stamped this on here with this paint. And you've got stuff like these are the lines that are supposed to go up and line up with the bands. And as you can see, there's a little problem there. So, I don't know. I would really love to find stamps that you could use to print what you wanted to print on things. There's a lot of stuff though that would have to be done. And you can see what it's supposed to look like down there, and it's not. So, and I don't know, we've got this up here, which I really wouldn't want to mess with. This is Hallicrafters up there. Hallicrafters CO. And finding something with the right font, size and font, that'd be kind of interesting. You know, maybe for this stuff it wouldn't be quite as much of an issue, but I don't know. But I really would like to. I really would like to restore the model number if I could, but to do that I'd have to sand all of this out, and I'm probably have to look for wrinkle paint, and then respray the bad areas. The problem is I could make certain areas look really good, and it's going to make the rest of it look horrible. I haven't tried to really clean this yet at all, but I don't think it's going to do much. There's so much dirt and so much, there's rust peeking through, I can see it. You know, this wasn't kept in a nice dry location, that's for sure. Yeah, there's no saving this, and you can see it's still very discolored, rust looking, and that would be so nice if it looked all, the rest of it looked like that. But it's not. So, on the plus side, when I bought this, I probably paid more than I should have. Probably should not have bought it, but I did. One of the things I was concerned is because this has a top firing speaker. I thought, you know, probably the thing I'm going to have the most trouble with is the speaker. The speaker could very likely be damaged. And this speaker sounds great. Really, no problems, no rattles. It's got, you know, for a small speaker, it's got a decent bottom end. It's good. So, so that was a nice surprise. And the fact that I was able to restore it and it's working pretty well, it's also good. If I wind up doing something with the case, then I'll come back and show it to you. I'm wrapping up here, and I'm not sure what I'm doing next, but I hope you'll join me.